30-1. So, okay, we're going to go over assignment number 1 here for Trig 2. So I'm going to graph at least 2 cycles of this. So before I can do that, before I can graph it, I probably want to state what the amplitude is because I have no scale and I have no scale for an x or y, so I need the amplitude and the period. So what we know about this is that the amplitude, all right, the word out, is the A value, so that means this amplitude is 3. Remember, the amplitude, I just write it down for this one too, because we're going to do the same thing, is always a positive number. So it's probably better to write the absolute value of A rather than just A, so that this one is 0.5 and not negative 0.5, like the A value says. Okay, the period, depending on which mode you're in this case, they want it in degrees to start off with. The period is always going to be the original period of a sine or cos graph divided by the b value. Okay, so it's going to be 360 divided by, I'm going to assume that this is a half here, 1/2. 1/2. So therefore, this is 720. Okay. Let's just go down and just do this one. Why not? I'll go up and graph those in a bit. This one's got to be in radians, though. Okay, so this one here, so this is going to be 2 pi over b. So I got 2 pi, my b value is 2. 2 is reduced out. I'm left with a period of pi. Okay, so let's do this first top one here. So I need to get 2 cycles. So that means my x-axis has to reach at least 1440. So I got to figure out how I'm going to create a nice little scale here so I can actually read this nicely. This is at least 2. Maybe I can go a little bit more if I wanted to. Now it says 20 things going across there. So what if I, what if I like that? If I divide it by 20, I get 72. Everything is 72. It's a very strange scale in that situation. Actually, it may not be too bad. We could just fudge it a little bit and say, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 720. And at the end here is 1440 degrees. Okay, I'm not too concerned about labeling each exact one here, but I know that halfway is 360. And then if I wanted to, I can add 360. Let's make it 1080. Wow. Okay, so that's going to help us draw that part. We have an amplitude of 3 though. 1, 2, 3, 4, 5, 6. So let's just say that this is 3 up here. That means 4, 5, 6. That means this is also -3. I'm just going to try to use as much of this graph as possible. So this is a cos graph. Okay, so the very key is that this is a cos graph. It doesn't have any horizontal phase shift done to it. So that means the top of this graph, and if you were to put it in Desmos, you can see what that looks like. The top of the graph is going to start on the y-axis here. And by the time it gets to one period done, it should be back at the top of the graph again. And by the time it gets to another period done, it should be back at the top of the graph again. Halfway between the two, it should be at the bottom. So it's going to go down to the very bottom, then back to the top. And then I'm just going to put that. Okay, so I'm just drawing out just where the bottoms of these graphs are. Where it's going to cross the x-axis is halfway between a crest and a trough. So 1, 2, 3, 4, 5. So that's going to be about 2.5. So it's going to be these points right here. Okay. So that's pretty much all I really need to give a good sketch now. I got some good key points here. So I'm just going to draw a nice smooth graph between all of these points here. That's probably my best one. There we go. Okay, so this one, we are going to do the same thing that we did before, but this time we're going to use sine, so that's another important piece. So when we do that, that means it's going to start on the the y-axis on the x-axis, right at the origin, going upwards. So I know that this is going to go this way. Actually, it's going to go back the other way because of the negative. It's being reflected. So this negative is very important too. All right, it's being reflected. I should have mentioned, I'm just going to write that here. Okay, so that's going to be going down there. Let's go through and just 1, 2, 3, 4, 5, 6, 7, 10. Right about here, that is going to be a pi. And then way over here is going to be a 2 pi. That gives us at least the 2 cycles. 1, 2, 3, 4, 5. Right about here, let's call that 0.5. And a 1, 2, 3, 4, 5. Let's call that negative 0.5. Okay. Yeah, so by the time it gets back to one period, it should be doing the exact same thing it started off doing. So it should be starting going downwards to that point there. It should go downwards to this point. So these are just my indicators of which way that graph should be going. So it's got to go down, up, and then back down. So by the time it gets halfway between these two, it should be coming back up through that axis. 1, 2, 3, 4, 5. And the same thing over here should be going through this one too. So I got all these zeros here. So I know where it's going to cross those, and halfway between them, there should either be a crest or a trough. So there should be a point right here, and there should be one right here. It looks like that. Yeah, and halfway here as well, there should be one right there. And then halfway at the very end here, right about there. Yeah, so it looks like I got a pretty good start here. So I'm just going to start by drawing that out. Making sure I get through all of the key points here. I'm not too concerned about being super precise about all the other points in between. I just want a good sketch of what this looks like. There you go. Very nice. Without using graphing technology, I should be able to determine the amplitude, the period, in both the radians and degrees of each of these functions. So the amplitude is pretty easy. Just follow the same logic before. It's the absolute value of A. So the amplitude of all of these is just that number that's sitting in front without the negative. So that one's positive 4. Everything else stays positive. My period is either 2 pi over B or 360 over B. So I can do both of those in one step. So I can go, well, the first one's pretty easy. I'm going to try to keep this exact value. So 2 pi over 3 is one of my answers. And I'm just going to go 360 divided by 3. So I should get 120 degrees. So there's my 2 periods. The next one's going to be the same idea. This one here, I'm going to go 2 pi divided by 1/3 and 360 divided by 1/3. Actually, I'm not going to put an equal sign there. I'm going to put a little comma there. So this first one is going to do a little flipperoonie there. It's a reciprocal. So 2 times 3 is 6. So that's 6 pi. And then whatever 360 times 3 is, 1080. There we go. Oh, that's my bad. What was I thinking about those? I was using the amplitude there when I shouldn't have been. So this one here, it's 1. That's my B value. So this is just going to be 2 pi and 360. Okay. Some days, you know, just not the best. This one here, the B value is 2. So I'm going to use that. So 2 pi divided by 2 is just pi. The 2's will reduce out. And this is going to be 180 degrees. Okay. And this one here, see, the best for last, apparently. My B value is 2/3. So I'm going to divide by 2/3 in all these cases. I guess these 2 cases. Now this one ends up being 3 pi. You do a little reciprocal, flips over, 2's will reduce out. And this one will be, 540. Let's punch in the calculator. There you go. Sorry about that mess up on B. At least I caught myself on that. We're going to do the same thing here, but this time we're going to find two other new things here, a phase shift and a vertical displacement. So remember that the amplitude is the absolute value of the A, the period, it doesn't specify. Well, I guess in the question themselves, like you notice this says pi and this one says degrees. So it's either 360 divided by B or 2 pi divided by B. My phase shift, as long as it's factored, I should be able to read that one pretty easily. It's my C value, right? Yeah, it's my C value. Okay. And my vertical displacement is my D value. So my amplitude is 5. My period is, because there's a pi here, I'm going to go 2 pi divided by my B value. Now, this is kind of a weird way to write these. This is just saying that these are already factored out for us. So sometimes they're not factored out for us, but I'm just going to add those in there to make it look easier to read. So this is going to be 8 pi. My phase shift is going to be pi over 3, because it's already been factored out, and then it's pi over 3, and that just determines which direction here. So pi over 3 left, because it's a positive number there. And my vert disp is 1 down. So I'm not going to just put a -1 there. Like my midline is y is equal to -1. That's my midline. But my vertical displacement is just 1 down. Okay, so this one's going to be pretty much the same procedure. It's pi, so I'm going to use 2 pi for my period calculation. My amplitude is just +0.5. Okay. My period is 2 pi divided by my B value, 2. So it's pi. My phase shift is pi units, which is pi rad, sorry, to the right. And my vert disp is 3 units down. I didn't include the units on this one over here. I should probably put those in there. Okay. The amplitude is 3. Period is going to, this one's going to be in degrees. So I'm going to go 360 divided by 4. So that's 90 degrees. My phase shift is 50 degrees to the left. So we factored for us, that's nicely. And my vert disp. Oh, I don't know what I spelled there. Let's imagine that's a big I. Okay. Is 6 units, because it's +6. It's going to be 6 units up. There you go. Whoa, it's a lot of writing. I'll graph 2 cycles of this guy. Okay, so they give us less information about what this looks like. The reason they don't put all the other axes in there, because there is a vertical displacement here. But before I graph this, I probably want to find a few different things about this, such as my amplitude. So what's the up and down part? The amplitude is 1. My period, because there's a pi there, we're going to use radians for this. So I'm going to divide by my B value there, I get a period of 2. So I know my graph's got to at least go 0 to 2 pi. I'll determine that in a bit. My midline, this would be a nice number to have, is going to be y is equal to -0.4. So I want to graph that. We'll have a phase shift. My phase shift is going to be pi over 12 to the left. Remember, when I draw these out, that's probably going to be the last thing I'm going to do. So I'm going to draw pretty much the graph with all the other transformations and then just kind of move it over And then maybe you can erase it, or I just have two different colors. Amplitude, period, midline. I'm going to get my range. The reason I want my range is I want to know where the maximum and the minimum of this graph is. So the minimum is going to be the midline minus the period. So I'm going to go negative 1.4. And then my max is going to be my midline, 0.4, plus the 1 of my amplitude is going to be a 0.6. The reason I want that is I want to know how tall I need to make this graph. Now, I didn't have to write all that out. Period is just XCR, so that's not going to help me too much. Yeah, okay. Now I could either do a negative cycle and a positive cycle, or two positive cycles, one after another. It's up to me. If I do have a negative and a positive, it means I've got to just cut this graph in half and go one way or the other. Now, maybe I'll do that just for the fun of it. Is that the middle? I'm going to count this out now. 1, 2. You just watch me count. What you don't see is there's a little black dot where my cursor is. It doesn't register on the program. So this is going to be 10. So this is right down the middle here. So I'm going to draw my x-axis right down that middle. Now I'm going to pull up my ruler. And draw my axes right here. Okay. And I could just put the x-axis right down the middle and then just make sure my graph fits in there. Or I can move my x-axis up and down to kind of even out the graph a little bit. So I am just going to put the x-axis right down the middle. Okay. So there are my two axes. I'm just going to label them. And I got my x-axis and my y-axis here. So I want to go a period in both directions. My period is pi, so I'm just going to label that positive pi. This one is negative pi. This is pi over 2 then. It's negative pi over 2. Obviously, we got 0 right down the middle. I guess I don't have to put a 0 there. Okay, so what can I do here? We need a scale that at least fits this here, since I made it 1.4. Let's just say that this. Oh, that's going to be tricky. Oh, maybe not. Okay. I think this will work out pretty good. 1, 2, 5. Oh, this is kind of weird. I didn't quite put that down the middle, did I? A little bit higher than lower. Yeah, whatever. I guess there was no middle line there. So I'm going to go 1, 2, 3, 4, 5. This is going to be negative. I believe I did that. Okay, I'll do that then. I'm going to right to the very bottom here. This is negative 1.4, 2, 4, 6, 8, 10, 12, 10. So this is 1. It's also negative 1. Okay. So there's my scale, looking pretty good. Okay, so what I'm going to do now is I'm just going to sketch the graph before I shift it sideways. So I'm just going to pick a color that represents this. Let's say the red graph, okay? Now there's no reflection on the outside here, right? So this is a positive number, so that means it's going to be going upwards through the origin, because that's what a sine graph does. And then by the time it gets to 1 period later, it should be doing the same thing. So it should be doing that. That means it's got to be going down this way. So the same thing's going to happen over here. It's going to be going down this way. Halfway between the 2 points. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. I should be at a crest. I'm going to be a crest at a maximum of 0.6. Oh, yeah, sorry. My bad. I put the midline in there. Maybe I should put that midline in there, because that's where the key is. The midline is at negative 0.4. 2, 4 right here. So that is my midline. I just dot that in there. That's going to be the important line. I don't know what I was doing before. Cool. Okay. Now I can draw those sine things. So through the midline, going upwards, down, then up, down, then up. Awesome. Halfway between, I should be at a maximum. 2, 4, 6. Halfway between, I should be at a minimum. Halfway between, I should be at a maximum. Halfway between that, I should be at a minimum. Yep. Looking good. You could try to find some zeros in here, but I'm just going to sketch what I have here. Okay, so that there is the graph before the horizontal phase shift. So what we're going to do with this now is we're going to move this graph ever so slightly, in this case pi over 12 in the left direction, so this direction here. Okay, just 1 second. Okay, so I just left to do some math on my scale here. Now pi over 12 is not going to be the nicest number for this scale. It's a very nice scale. Fits pi perfectly, half pi, but pi over 12, which is, if you go through it, it's 15 degrees. If you change it to 15 degrees, then every single one of my ticks here, it's 180 divided by 20. If I did that, all my ticks are 9 degrees. So 9 degrees, 9 degrees, 9 degrees, all the way up to 180 degrees. Now, I need to move this thing over 15 degrees, but every tick is 9 degrees. So based on my math here, I'm just going to go 15 divided by 9. I had to move this thing over 1.6 or 1.7 boxes to the left. Okay? So I'm just going to pick all my key points and move them over 1.7 or 6-ish, 1.6 repeating boxes. There's a point right there. That's 1 over. So that's going to move over that many spots. Same thing here. This one's going to move over. So I'm just going to pick all these points here and just slightly move them over 1 2/3 of a box over. So you're going to see some points pop up here. It's 1 2/3. Yeah. To the left. So I'm going to move to the left here. This one's not going to be able to go off. There we go. Cool. Okay, so my new graph is going to look like this. So I got a crest right here. Oh, I didn't do this one here. Right here. A trough right there. Go up. Actually, that looks pretty close to being almost through that. If you want, you can find out where it crosses the y-axis by putting 0 into this graph up here. I'm not too concerned about that. Neither should you. Just doing a sketch here, and then I don't know exactly where this goes. Let's just keep going that way. So the blue graph is the graph that we're worried about here. There's my blue. There you go. Fun little graph. So this is going over, I'm just going to write that in, pi over 12. So that last question was a lot of work, but it's gotten done. There we go. I'll see you in the next video. Bye.